Hey guys, welcome back. Mrs. Saunders here. We're continuing our journey in geometry by talking about angle relationships. So today we're going to learn about the different relationships that angles can have and learn how angles get prom dates. Just kidding. Clearly not that kind of relationship. So our first term or terms today is adjacent angles. And those are angles that have a common vertex and a common side, like this. Basically, there's two angles and they share a wall. But they share a wall, comes off the same vertex there. A specific kind of adjacent pair is called a linear pair. They come off the same line and share a side. So here's a line, and if I add a ray to it, then look, I've created these two angles right here. And those two angles are called a linear pair. And you can think about it as a linear pair, or just look at the name. It's a line pair. And of course, these are also adjacent because they share that wall, that green wall there. Now, vertical angles. These will be a part of our geometry from now until the end of the course. So if you weren't listening before, stop what you're doing and start listening now. Vertical angles are non-adjacent congruent angles formed by two intersecting lines. They're angles that are opposite each other. So if I have a line and I cross it, intersect it with another line, now I've created four angles. See those? And the vertical angles are the ones that are opposite each other. They're the ones that create like the same size V. So 1 and 2 are congruent, and then angles 3 and 4 are also congruent vertical angles. So just to practice a little bit, like if this guy is 40 right here, what would the measure of that angle be? Also 40. And if this angle is 140, what would that angle be? Also 140 degrees. Those are vertical angles. So let's practice a bit with this crazy looking figure here. Name two acute vertical angles. Well, to have vertical angles, we need intersecting lines. And acute means that it's less than 90 degrees. All right, so here's two intersecting lines. And hidden in this figure here is some information. That box right there is telling me that this angle, FKJ, that's a 90 degree angle there, which means that anything less than that is acute, which means that these two guys here, see these two angles, this one and this one, those are acute vertical angles. So EKH and FKG. Notice K is the vertex of each of those, and K is the middle letter each time I name them. Okay, how about two obtuse vertical angles? So obtuse is greater than 90 degrees. Actually, we can just use the same intersecting lines and choose the opposite pair of angles that's created. So EKF and HKG. All right, name a linear pair. That's next. I think there's a bunch of linear pairs in here, but let's take this line right here and this ray coming off of it. And now we've got two angles right here. There's this one and this one. They share a line, they share a side. So EKH and EKF. And then finally name two acute adjacent angles. Again, here's our right angle right here, FKJ. So anything less than that is going to be 90 degrees. Well, actually, we have another line in here that creates two angles. So each of these is going to be less than 90 degrees, and they share that side right there. So those are two acute adjacent angles. More vocabulary. Complementary angles. These are angles that say nice things to one another. No. Complementary angles. Two angles are complementary if they have measures that add up to 90 degrees. So again, this box right here is what tells us that this big angle is 90 degrees. And these two angles create that 90 degree angle. So if we add them up, angle 1 plus angle 2, we get 90 degrees. So those are complementary angles. Now the thing is, right here, they're next to each other, but they don't have to be next to each other. They can be floating in space. As long as their measures add to 90 degrees, they're considered complementary angles. Supplementary angles are two angles that have a sum of 180 degrees. So good example of those are any linear pair. Because actually a line is 180 degrees. And so we've got these two angles here that make up that line. These are a linear pair, and they add up to 180 degrees. All linear pairs are supplementary. So just remember that. All linear pairs are supplementary. And again, it doesn't have to be a linear pair. The angles don't have to be anywhere near each other. They can be off floating in space as long as their measures add up to 180 degrees. Perpendicular are line segment arrays that form right angles. So we've got an intersecting line and an intersecting ray here. And each of these angles is 90 degrees. You can see by the box there. So when those intersect, they create 4 right angles, which means those lines are perpendicular lines. So we say the line AB is perpendicular to the ray CD. So that's what this symbol means. Perpendicular. And you can tell that because the symbol is 2 little perpendicular lines. All right, a little bit more practice here. Can you name 2 vertical angles? There's a bunch of them in there, but I'm going to pick AD and FG. Those are vertical angles. Name 2 adjacent angles. Again, there's a bunch of them in here, but AB, those are adjacent angles. They share a wall. FH, those are adjacent angles. Those are also linear pairs. Name 2 supplementary angles. Well, remember I said any linear pair is a supplementary angle. They add to 180, so I'll pick C and D and E and G. And then name a linear pair. Well, we've already done that a couple times, but C and D and E and G again. Got a different figure here, so name 2 complementary angles. Those are angles that add to 90 degrees. So again, we've got this little hidden information, right? This BGD, oh, there I did it in blue. That's a 90 degree angle. And so the 2 angles that make it up, those would be the complementary angles, BGC and CGD. Those add together to equal 90. All right, let's try this problem. If the measure of angle RTS, let me just highlight that real quick. RTS, that's what we're talking about, is 8x plus 18. See how I'm just filling in the information as I go? Your brain needs to be able to just organize the information. So put the information down, and then you don't have to worry about remembering it. So RTS is 8x plus 18. Find the value of x so that TR is, remember this, perpendicular to TS. If they're perpendicular to, right there, see? They're perpendicular, that means 90 degrees. That means 8x plus 18 has to equal 90 degrees. So we'll subtract 18 from both sides. 8x equals 72, divide both sides by 8, and you get x equals 9. All right, this one's a doozy. The measure of the supplement of an angle is 36 less than the measure of the angle. Find the measures of the angles. Oh. Okay, so we've got 2 angles, and one is a supplement of the other, meaning they add to 180 degrees. They're supplementary. So let's take the big one and name it x. And it says the other one is 36 less than that. So we'll name that one, well, x minus 36. It's 36 less than the big one. And we know that these 2 angles add to 180 degrees. So that's what I'll do. I'll add them together. We've got the big angle right here and the smaller angle. Add those and equal them to 180. Combine like terms. Add 36 to both sides. Divide by 2. So the big angle is 108 degrees. The small angle then has to be 72 degrees because 108 plus 72 is 180. Those are some of the angle relationships. Thanks for being here.